So here come the last couple examples in this lesson. Don't worry about the probability portion of it right now. Just think about solving logarithms. You're not even going to have to solve that many tonight. But, hey, that's just something to think about. Okay, so now we talked about what happens when you have an exponent on both sides. If the bases are the same, the exponents are equal. If the logs on both sides are the same base, what's inside must be equal. But what happens when I have a mix of logs and other numbers? Well, this is where your properties come in handy. Okay? If you're adding or subtracting or even multiplying by a number outside, you have these properties, the product and quotient rules for logarithms. So I can take something like this. I'm going to go back to that original lesson that I had. Because when I combine these, even though it may not look as pretty as I would like, I now have one logarithm problem. And if I can't solve a logarithm, I'm going to rewrite it as an exponential. So I'm going to rewrite this one right here. I'm going to say 3x plus 1 over 4 is equal to my base 10 to the second power. All right? So once it's written as an exponential, now I'm probably going to be able to solve this. I'll multiply both sides by 4. Multiply both sides by 4. Catching that? I'm going to subtract 1. And now, oh my goodness, I will actually divide both sides by 3. X is 133. But the whole point is, going back to that same idea, if you can get it to a single logarithm, you can rewrite it. You can make an exponent out of it and solve it. So you just have to look at these, and if they're being added, you multiply them. If they're subtracted, you divide them. You're going to use your properties to create one logarithm. One last time, the product rule is illustrated here, but the real key is I have a number all by itself. If I have some kind of number or some kind of value there, other than just logs, I'm going to have to do something to combine these logarithms and solve it. So, this is log base 4, huh? So I have to multiply these together. And it equals 2. Well, that is quite a bit of multiplying. I think if I were to FOIL this, let's see, minus x and then minus 3x. So minus 1x and minus 3x makes minus 4. And the rest of that will be 1. Okay, I've multiplied. In this case, I had to FOIL when I was multiplying. Oh well, we move on. I have a logarithm. I don't know how to solve it. I can't plug that in my calculator, but I can rewrite this into a form that I will be able to solve. That's 4 squared. The base becomes the base. The exiled number becomes the exponent. It's all equal to what's left. All right, and I know that 4 squared is 16. And so now we come to the final elements of this problem. Going all the way back to chapter 2, we are revisiting the idea of how do you solve a quadratic? I could, with this number, complete the square, but it's ugly when I have a coefficient other than 1. I could also try and factor. By the way, it actually works. I could write 3x and 1x and start trying to plug things in, but that's going to be hard too. And if you're allowed to use a graphing calculator, by all means, you could. But right here, I'm going to go ahead and use not the Pythagorean theorem, the quadratic formula. I know that x will be equal to negative b plus or minus b squared minus 4 times a times c. Okay, I cheated. I did a little math in my head before I started this problem. And now I see x is equal to 4 plus or minus 196 over 6. Ladies and gentlemen, the square root of 196 is 14. So when I combine these, I can look at 2 possibilities here. Either I have 4 plus 14 divided by 6, or I can take 4 minus 14 divided by 6. Either way, I'm going to get my possible solutions. Positive 3 or negative 1 and 4/6, or negative 1 and 2/3, or negative 1.6 repeating. Hey, I just want a correct answer. I'm not worried about the form. Okay? So, if you have multiple logarithms, not just one on each side, but multiple logarithms and perhaps another number sprinkled in, please use those properties, combine the logs as well as you can, and then rewrite it as exponential to solve it. You use the inverse to solve equations. I hope this works well for you. Good luck.